Forget the sterile language of procurement documents and the clean lines of an engineering schematic. The soul of an attack helicopter is forged in the violent physics of combat. It is in the precise whine of a turboshaft engine spooling up, the menacing glint of a sensor turret swiveling to lock onto a heat signature miles away, and the brutal finality of a 30mm cannon shell impacting armor. This is not a realm of abstract strategy, but a brutal, tangible reality where every design choice, from the composition of a rotor blade to the algorithm in a fire control computer, is a life-or-death wager. In this arena, two titans now circle each other. One is the Boeing AH-64 Apache, the battle-scarred champion of the West, a machine whose silhouette is synonymous with American air power. The other is the Changhe Z-10 Fierce Thunderbolt, the lean, ambitious challenger from a rising superpower engineered to contest that dominance. To pit them against each other is not merely to compare hardware. It is to witness a clash of doctrines, a duel between industrial philosophies, and a preview of the next chapter in the savage art of war fought between the treetops and the sky. The doctrinal DNA of these two machines was written decades apart, in different jungles and on different planes, shaped by opposing anxieties. The American concept of the attack helicopter was born in the crucible of Vietnam. Initial efforts to simply bolt weapons onto transport helicopters like the Sikorsky H-34 proved inadequate against the increasing intensity of ground fire from Viet Cong and NVA troops. This experience led to a critical doctrinal split, the separation of transport and attack roles. The result was the development of dedicated gunships and the refinement of hunter-killer tactics, a deadly aerial ballet that defined American rotary wing employment for generations. Light, nimble scout helicopters like the Hughes OH-6A Cayuse, nicknamed the Loach, would fly low and slow, deliberately drawing enemy fire. Once the hidden enemy revealed their position, the killer, a heavily armed Bell AH-1 Cobra circling at a higher altitude, would swoop in to deliver a devastating barrage of rockets and minigun fire. This philosophy prioritized standoff engagement, precision, and survivability through tactics like nap-of-the-earth flight, using terrain to mask the helicopter's approach. The AH-64 Apache was the ultimate technological culmination of this doctrine, conceived not for counterinsurgency in jungles, but to halt the tide of Soviet armor expected to pour through the Fulda Gap. Its purpose was singular and terrifying: to be a flying tank destroyer, a sniper capable of killing from behind a hill, deep in enemy territory. The Soviet Union, observing the American experience in Vietnam, drew a starkly different conclusion. Where the Americans saw the need for a specialized hunter, Soviet designers like Mikhail Mil envisioned a flying tank, or more accurately, a flying infantry fighting vehicle. Their doctrine was not one of standoff precision, but of brutal combined arms assault. The result was the Mil Mi-24, affectionately nicknamed the Crocodile. It was a beast of a machine, heavily armed and armored, but with the unique and somewhat baffling ability to carry a squad of 8 fully equipped soldiers in its passenger cabin. The Hind was not meant to hide behind hills. It was designed to lead the charge, to suppress enemy positions with overwhelming salvos of unguided rockets, and then disgorge troops to seize critical objectives like bridges or command posts, acting as an integral part of the ground offensive. This philosophy prioritized offensive momentum and raw firepower over the surgical precision sought by the West. It is from this divergent lineage that the Z-10 emerged. Chinese designers, starting their dedicated attack helicopter program in the mid-1990s, had the benefit of studying both approaches. They sought Russian consultation from the Kamov Design Bureau, but ultimately rejected the heavily armored flying tank concept, opting instead for a lighter, more agile airframe. This decision, driven partly by design philosophy and partly by the harsh reality of engine limitations, created a machine that embodies a hybrid doctrine, possessing the tandem seat, dedicated attack layout of a Western helicopter, but with a unique emphasis on agility and a weapon suite that suggests a willingness to engage in direct aerial combat, a concept far from the minds of the Apache's original designers. The AH-64 Apache is an exercise in engineering for a high-intensity battlefield where every component is optimized for survivability and lethality. Its airframe, while appearing conventional, is a fortress built primarily of aircraft aluminum alloys, but designed with meticulous attention to combat resilience. The entire structure is rated to withstand hits from 12.7 mm projectiles from any angle, and critical areas can tolerate direct impacts from 23 mm high explosive or armor-piercing rounds, a common caliber for Soviet-era anti-aircraft guns. This protection is not merely skin-deep. The design incorporates over 1,100 kilograms of armor, including a transparent blast shield separating the pilot and co-pilot gunner, CPG, in their tandem cockpits, ensuring that a single hit is less likely to incapacitate both crew members. The rotor blades themselves are designed to be damage-tolerant, constructed with 5 stainless steel spars that allow them to sustain projectile strikes and continue functioning. The fuel system is self-sealing, and the entire airframe is designed to meet the stringent MIL-STD 1290 crashworthiness standards with heavy-duty, fixed tailwheel landing gear whose struts are engineered to collapse in a controlled manner during a hard landing, absorbing immense kinetic energy to protect the crew. This is not a machine designed for elegance. It is designed to fly through a wall of lead, complete its mission, and bring its crew home. Powering this aerial behemoth are 2 General Electric T700 turboshaft engines, a family of power plants whose own development was a direct result of lessons learned in Vietnam, emphasizing reliability, modularity for ease of maintenance, and performance in hot and high conditions. The initial AH-64A models were fitted with the T700 GE701 variant, producing around 1,265 kilobars, 1,096 shp each. As the Apache's mission systems grew in weight and complexity, the engines evolved in lockstep. Later models received the uprated T700 GE701C, pushing output to 1,342 kilowatts, 800 shp. The current AH-64E Guardian variant is equipped with the formidable T700 GE701D, each delivering up to 1,487 kilobars, nearly 2,000 shp. This consistent and deliberate growth in power has been the key enabler of the Apache's longevity, allowing the nearly 50-year-old airframe design to accommodate successive generations of heavier, more power-hungry sensors and weapons, keeping it at the apex of the world's attack helicopter fleets. The true essence of the Apache, however, lies not in its brawn, but in its senses. The original A model revolutionized night combat with its target acquisition and designation sight, each pilot night vision system, TADS PNVS. A rotating turret on the nose containing a forward-looking infrared, FLIR system that allowed the crew to navigate and attack with precision in total darkness and adverse weather. This system has since been upgraded to the modernized TADS PNVS, also known as Arrowhead, which provides vastly improved image resolution and greater standoff ranges, allowing crews to identify and engage targets from farther away. Yet the system that truly defines the modern Apache is the AN/APG-78 longbow fire control radar, housed in a distinctive dome atop the main rotor mast. This placement is a tactical masterstroke, allowing the Apache to remain concealed behind terrain or buildings, exposing only the radar dome to scan the battlefield. Operating in the K-band, this millimeter-wave radar is resistant to jamming and ground clutter and can automatically detect, classify, and prioritize up to 128 targets within a 30-second span, engaging up to 16 of them simultaneously. Initially developed with an 8-kilometer range, Subsequent upgrades have more than doubled this and added a maritime mode for engaging naval targets. This system transforms the Apache from a mere gunship into an airborne battlefield commander, capable of unparalleled situational awareness. The talons of this predator are as sophisticated as its eyes. The primary gun is the 30mm M230 chain gun, an externally powered cannon with a deliberate rate of fire of 625 rounds per minute, fed from a magazine holding up to 1,200 rounds of M789 high-explosive dual-purpose HEDP ammunition. Each M789 round can penetrate over 25mm of rolled homogeneous armor, making it lethal against light armored vehicles and personnel. The gun's most revolutionary feature is its integration with the integrated helmet and display sighting system, IADSS, which slaves the gun's turret to the gunner's head movements. Where the gunner looks, the gun points. For area suppression, the Apache carries Hydra 70 2.75-inch rockets in 19-tube M261 launchers, capable of delivering a variety of warheads from high-explosive to flechette and illumination rounds. In a perfect example of iterative modernization, these unguided rockets can be transformed into precision munitions with the addition of the Advanced Precision Kill Weapon System, APKWS, Laser Guidance Kit. The Apache's premier weapon, however, is the AGM-114 Hellfire missile. This weapon has evolved alongside the helicopter. Early variants were semi-active laser-guided, requiring the helicopter or another platform to keep a laser spot on the target until impact. The advent of the longbow radar brought with it the AGM-114L Longbow Hellfire, which uses its own active millimeter-wave radar seeker to home in on targets identified by the APG-78, creating a true fire-and-forget capability. The latest iteration, the AGM-114R Romeo, features a multi-purpose warhead that combines shape-charge anti-tank capabilities with a blast fragmentation sleeve, allowing a single missile to effectively engage everything from heavy tanks to buildings and patrol boats. With a range exceeding 8 km and a speed of Mach 1.3, the Hellfire allows the Apache to kill with impunity from well outside the range of most battlefield air defenses. The Apache is not merely a collection of parts, it is a deeply integrated weapon system, a testament to a design philosophy that anticipated technological growth from its inception. The airframe was built with the margins to accept more weight and power, and the longbow radar was not an afterthought, but a planned evolution that fundamentally rewrote the rules of engagement for attack helicopters, cementing the Apache's status as the benchmark against which all others are measured. The Changhe Z-10, known as Fierce Thunderbolt, presents a fascinating counterpoint, a machine born from a complex mix of foreign assistance, indigenous innovation, and pragmatic compromise. Its airframe adopts the classic Western tandem seat configuration, but its execution is distinct. The fuselage is remarkably slender, featuring a narrow rhombic cross-section with canted sides that form a hexagonal frontal profile, a design choice explicitly aimed at reducing its radar cross-section, RCS. This focus on signature management is a core element of its design philosophy. The airframe is constructed from a mix of aluminum alloy and a significant proportion of composite materials, accounting for roughly 30% of its mass, with radar-absorbent materials applied to further decrease its detectability. Its protection scheme is more selective than the Apache's all-encompassing armor. The cockpit canopy is protected by 38mm thick bulletproof glass rated to stop 7.62mm rounds, while composite armor under the cabin and around critical components provides protection against 12.7mm machine gun fire. The export-oriented Z-10ME variant enhances this with modular bolt-on armor packages made from advanced ceramic and graphene-based materials for the cockpit and engine compartments. A key feature is its sophisticated infrared signature suppression system. The engine exhausts are mixed with cool air, and on the latest ME variant, the nozzles are redirected to face upwards, using the downwash from the 5-bladed main rotor to further disperse the hot exhaust gases, making it a more difficult target for heat-seeking missiles. The story of the Z-10's propulsion is a saga of ambition meeting geopolitical reality. The initial prototypes were powered by two capable Pratt & Whitney Canada PT6C-7C turboshaft engines, each producing about 1,142 kilobars, 1,531 shp, which gave the airframe excellent performance. However, U.S. government intervention and sanctions cut off this supply, forcing Chinese engineers to turn to the indigenous WZ-9 turboshaft engine. Early versions of the WZ-9 were significantly underpowered, producing only around 957 1,000 kcal 1,283 1,341 shp. This power deficit had a cascading effect on the entire design, forcing a drastic weight-saving program that saw the removal of some subsystems and a reduction in armor on the initial production batches, preventing the helicopter from carrying its maximum intended payload. It is a classic case of an airframe waiting for its engine. This shortfall has only recently been rectified with the development of the improved WZ-9C and WZ-9G variants, which now produce power in the 1,200 kcal, 1,600 HP class, finally allowing the Z-10ME to realize the full potential of its design. The sensory suite of the Z-10 reflects a different evolutionary path than the Apaches. Its primary targeting tool is a nose-mounted electro-optical turret, designated WXG-1006, which houses the standard array of FLIR, a daylight TV camera, and a laser rangefinder designator. While effective, the true innovation lies in its defensive systems. The Z-10 is equipped with the YH-96, touted as China's first fully integrated electronic warfare suite. This system combines radar warning receivers, RWR, laser warning receivers, LWR, electronic support measures, ESM, and electronic countermeasures, ECM, into a single, cohesive package that can automatically analyze threats and deploy the appropriate decoys or jamming signals. A mast-mounted millimeter-wave fire control radar, analogous to the longbow, is a key feature, but unlike on the Apache, it is not standard across the entire fleet. It is more commonly seen on the Z-19 Scout helicopter, suggesting a doctrinal preference for hunter-killer teams, though it is a central component of the high-end Z-10ME export variant. The Z-10's arsenal is both versatile and unique, revealing a distinct tactical philosophy. Its chin turret is flexible, capable of mounting a 23 MIRSO or 30 mm cannon, or even a 40 mm grenade launcher, depending on mission requirements. Its 4 hardpoints, expanded to 6 on the Z-10ME, can carry a mix of unguided rockets and a formidable array of guided munitions. The primary anti-tank weapon is the HJ-10, or Reed Arrow 10, Air Launch Designation AKD-10. This missile is not a simple Hellfire clone. Its most notable feature is its fiber optic guidance system, which spools out a thin wire behind the missile, transmitting a real-time video feed from the missile seeker back to the gunner's display. This allows for man-in-the-loop control, enabling the gunner to attack targets not in the helicopter's line of sight, NLOS, correct the missile's course mid-flight, or even switch targets after launch. With a range of up to 10 kilometers and a tandem heat warhead capable of penetrating a stated 1,400 millimeters of armor, it is an exceptionally lethal weapon for ambushes from complete defilade. Perhaps the most telling component of the Z-10's armament is the TY-90 air-to-air missile. Unlike the Stinger, which is an adapted infantry weapon, the TY-90 was designed from the ground up as a dedicated helicopter dogfighting missile. It is a formidable weapon, boasting a speed of over Mach 2, the ability to pull 20 G-turns, and a 3-kilon warhead with a laser proximity fuse specifically designed to shred an enemy helicopter's rotor system. The standard carriage of such a potent anti-helicopter weapon suggests a doctrine that not only anticipates but actively seeks air-to-air engagements, a clear divergence from the Apache's ground attack focus. The Z-10's development is a story of a leapfrog strategy. It has incorporated modern concepts like stealth shaping and integrated EW from the outset, while pragmatically working to overcome its technological weak points, most notably its engines. The Z-10ME is the culmination of this effort, a machine that has finally closed the power gap and, in doing so, has become a credible and dangerous adversary on the world stage. A direct juxtaposition of the AH-64 Apache and the Changhe Z-10 reveals more than a simple list of competing specifications. It exposes two fundamentally different philosophies of aerial combat, akin to a heavily armored juggernaut versus a nimble duelist. The Apache is the juggernaut, a product of a military doctrine that seeks to dominate the battlefield through technological superiority, information supremacy, and overwhelming, resilient firepower. Its maximum takeoff weight of over 10,433 kilos is a testament to this philosophy, accommodating extensive armor, redundant systems, and the powerful sensor suite crowned by the longbow radar. It is designed to absorb punishment, process a deluge of battlefield data, and function as the central node of a networked attack, distributing destruction with its versatile arsenal. Its relatively shorter combat radius of around 476 kilometers is a reflection of a doctrine built around established forward operating bases and a robust logistical tail. The Z-10, in contrast, embodies the duelist's ethos. It is significantly lighter, with a maximum takeoff weight of around 7,000 kilometers, and its design prioritizes agility, a lower radar and infrared signature, and specialized weapons to exploit an opponent's weaknesses. Its superior range of 800 kilometers suggests a doctrine that may require operating with greater autonomy or from more dispersed, less developed bases. While the Apache relies on its comprehensive armor and the situational dominance granted by the longbow radar for survival, the Z-10's survivability is rooted in not being seen or hit in the first place, using its slender, stealth-shaped fuselage and advanced YH-96 electronic warfare suite to evade detection and defeat incoming threats. This philosophical divergence is most apparent in their weapon systems. The Apache's AGM-114R Hellfire is a master of all trades, a single multi-purpose missile that simplifies logistics and gives the commander immense flexibility to engage any target of opportunity. The Z-10's arsenal is more specialized. The fiber-optic guided HJ-10 missile is a perfect tool for a duelist, allowing for ambushes and non-line-of-sight attacks that minimize the helicopter's exposure to direct fire. The standard inclusion of the TY-90 air-to-air missile is the most telling feature. Whereas the Apache can carry Stinger missiles, this is largely a secondary self-defense capability. The Z-10's doctrine, however, clearly includes the active hunting of other aerial platforms, particularly enemy helicopters. The TY-90 is not a defensive weapon. It is an offensive tool designed to win an aerial duel, a direct challenge to the air superiority that platforms like the Apache have long taken for granted. Therefore, to declare one superior to the other based on raw numbers is to miss the point. The Apache is designed to command the battle. The Z-10 is designed to win the engagement. In a hypothetical confrontation, the Apache would leverage its longbow radar to detect, classify, and engage multiple Z-10s from standoff range with fire-and-forget Hellfire missiles before the Chinese helicopters are even aware they are being targeted. The Z-10's counter would be to use its lower signature and nap-of-the-earth tactics to close the distance, using its agility to evade detection and then employing its own specialized weapons, either the NLOS HJ-10 from a concealed position or the potent TY-90 in a high-G, close-range dogfight. It is a contest between a system designed for overwhelming situational dominance and one designed for tactical lethality and surprise. The relentless pace of technological change and the shifting realities of the modern battlefield, increasingly populated by sophisticated air defense systems and swarms of unmanned aircraft, are forcing both platforms down a path of continuous evolution. For the Apache, the future extends to 2060 and beyond, a remarkable lifespan for an airframe designed in the 1970s. This longevity is made possible by a forward-looking modernization strategy centered on the AH-64 version 6.5 and the adoption of a modular open systems architecture, MOSA. This approach treats the helicopter less like a fixed piece of hardware and more like a smartphone, allowing for rapid and cost-effective integration of new capabilities through software updates rather than factory rebuilds. The core of this modernization is the enhancement of manned-unmanned teaming, a MUM-T. This is not merely the ability to view a drone's video feed. It is a deep integration that allows Apache crews to achieve level of interoperability, LOI 3 and 4, meaning they can take direct control of a UAS's sensors and even its flight path from their cockpit. This allows an Apache to send a drone like the MQ-1C Gray Eagle deep into contested airspace to find and designate targets, which the helicopter can then engage from a safe standoff distance, dramatically increasing crew survivability and operational reach. Future plans include the integration of launched effects, air-launched drones that can act as sensors, decoys, or kinetic weapons, and new long-range precision munitions. To support these power-hungry systems, the Apache fleet is slated to eventually receive the new, more powerful and efficient General Electric T901 engine developed under the Improved Turbine Engine Program, ITEP. This strategy effectively transforms the Apache from a frontline attacker into a quarterback in the sky, a command and control node orchestrating a team of unmanned assets. The Z-10's evolutionary path is one of rapid maturation, culminating in the Z-10ME export variant, which is less an upgrade and more the helicopter the Z-10 was always intended to be. This version systematically addresses the shortcomings of the initial production models. The new, more powerful WZ-9G engine provides the necessary performance for hot and high environments and allows the airframe to carry its full design payload. This includes the addition of the mast-mounted millimeter-wave radar, bolt-on armor packages, and an expanded array of 6 hardpoints. The Z-10ME also incorporates a sophisticated, modern defensive suite that includes a missile approach warning system, MAWs, and critically, a directional infrared countermeasures, DIRCM system, a high-end technology that uses a laser to blind incoming heat-seeking missiles and is still rare on many Western helicopters. The successful export of the Z-10ME to Pakistan, a nation that was denied access to American and Turkish alternatives, marks a significant geopolitical victory for China. It establishes the Z-10ME as a credible, high-performance alternative for nations outside the Western defense ecosystem and provides a crucial combat testing ground for the platform. While its unmanned integration is not yet as mature as the Apache's MUM-T, the Z-10ME is being equipped with the necessary building blocks, including compatibility with loitering munitions like the CM501XA and air-launched drones like the SW-6. Both modernization programs demonstrate a clear convergence in thought. The future attack helicopter will act as a mothership for unmanned systems. The Apache is refining its already mature capability, upgrading its brain for a new way of fighting. The Z-10ME, having finally received the powerful body and sharp senses it always needed, is now ready to develop that same intelligence. In the final analysis, the AH-64 Apache and the Changhe Z-10 are more than just competing machines. They are embodiments of their respective eras and strategic postures. The Apache is the product of a superpower at the height of its technological dominance, a platform built on decades of combat experience and immense sustained investment. It is a mature, perfected system whose every component has been tested and refined in the crucible of war. Its high acquisition and operational costs, with cost per flight hour figures often cited in the thousands of dollars, reflect this complexity and proven capability, making it the undisputed gold standard of attack helicopters. Its modernization path is one of maintaining dominance, evolving its role from a direct combatant to a networked commander of unmanned systems to ensure its relevance for another half-century. The Z-10, on the other hand, is the story of a nation's meteoric rise. It is a testament to a pragmatic and often clever design process that navigated significant technological hurdles, particularly the critical engine deficiency that constrained its early potential. It is a machine that seems to have required not a ritual dance to start up, but a series of back-alley deals for foreign parts and a monumental indigenous engineering effort to finally work as advertised. The evolution from the compromised initial production model to the formidable Z-10AE in little more than a decade is a stunning achievement, showcasing an iterative development cycle that is proceeding at a breathtaking pace. Its lower projected cost and freedom from the political strings often attached to Western hardware make it a potent tool of defense diplomacy and an attractive option for a growing number of nations. Their ongoing competition is a microcosm of the 21st century's defining strategic rivalry. While the battle-proven Apache remains the benchmark for capability and integration, the Z-10's rapid trajectory from a flawed copy to a credible, technologically advanced peer cannot be ignored. The Fierce Thunderbolt may not have the Apache's long list of battle honors, but it represents a future where the sky is no longer the exclusive domain of a single apex predator.